Ladies and gentlemen, today I will talk to you about your new AI research tool, Consensus. My name is Yannick Stedler. I am information consultant for medicine, environmental science, and referent e-media at the University Library of Basel. I will be talking about hallucinations and retrieval-augmented generation, RAG for short. I will talk about Consensus, how it works, and provide a small live demo and a short conclusions. AI hallucinations. AI-generated research writing, while useful, can contain critical mistakes that jeopardize accuracy and credibility. 3 common error types are typically present. Entirely fabricated things. So, for example, literature that would fit very, very precisely, suspiciously precisely to your study system. And this, like many things that are too good to be true, they're not. They are not that difficult to spot if you have topic expertise. Misinterpreted findings. These are much more difficult to spot. Like, for example, the AI would say that cite a paper, but say that it is conclusively demonstrates something instead of saying that it hints that there is a relationship between 2 things. So basically, misinterpreting the findings of the study. And this is really hard to know because, of course, it is on topic, but it misinterprets what the study says. The third type of error is when the AI writes things that are overly generalistic. Typically like a very, very hedged manuscript. This is what you would call a word soup. And this is, of course, useless and easy to spot, but it has tended to be less and less common with the more recent AI models. These problems are especially common in references because the output of these models tend to be statistical. The references, however, cannot be statistical. So the page number cannot be a value between two in a bracket. It has to be this number to this number, and this is hard for a statistical system to achieve. And in order to solve these problems, RAG tools were invented. So what does RAG do? RAG has 4 key stages. First, indexing. So the system converts a source data, for example, the abstract and semantic scholar, into embeddings and stores these embeddings in a vector database. So it's really a semantic vector database where the meaning of the different topics of the abstract is coded. Then, when the user makes a query, the system selects use this vector database to select the few most relevant abstracts using similarity measures. Then the system injects pieces of these abstracts into your prompt. So your prompt starts with a question, and the system injects these relevant abstracts into the prompt. And then the large language model digests this and produces an answer grounded in both the user query and the retrieved context. There are different services doing this on the market. We have benchmarked these services, and we have finally decided to license Consensus. Consensus is licensed for the whole university. So if you have email address ending by univas.ch or stud.univas.ch, you can register, and then you have full access to Consensus. So this is what the Consensus page looks like, and you just ask a question. It's really kind of similar to Google, really. So in this case, what is the current consensus on gut infections and Alzheimer's disease? And what you get is an answer, really, with the bullet points. And after each bullet point, you have a series of citations, so the literature is cited. However, because the large language model used is ChatGPT, it has a certain flexibility. So if instead you say, what is the current consensus? You say, write an essay, write a review on the current consensus of gut infection, Alzheimer's disease, then you get an essay. And so this is actually much more practical if you're just looking for a sentence that you could directly integrate into a manuscript or use for a manuscript as a template for a manuscript. And again, you see that each of these statements has a citation. And you see different sections of this essay and a list of literature. You can collapse the list if you want to see it in a more compact format. And you can export this list to in a literature management software if you still use such a tool. Also, another feature that consensus provides is a consensus meter. So it transforms your question into, modifies it a little bit, and then asks this modified question to the series of papers it has cited that found relevant, and tells you, for example, how many support the hypothesis, how many says there may be a link, and how many say it's mixed, and how many says no, and gives you at the same time a form of report about this question, again with citations. It's quite a useful tool, especially if you're new to a field. So for example, even a table here telling you what is what. If we decide to have a look at one of these papers in precisely, you can click on it, and then we land onto the page, if you want, of that paper. And below, you have this option, ask this paper. So if you use this, in this case, there's a little bit of a bug. The paper should be available because it's open access. But if you upload the paper like this, the PDF, you can really directly ask questions to the paper, and then the system will provide you an answer based on the content of the paper. In this case, I decided to ask the typical nasty question of reviewers who want to reject your manuscript. What are the main weaknesses of the paper? And then the system provides you an answer. For example, there are potential confounding medical uses, there's maybe some problem with the small sampling, etc., and the design of the sampling, for example. Now I will try to provide you with a little bit of a demo. So here, let's go to consensus here. So this is the effect of Alzheimer's disease. And this is the same question, really, a bit rephrased. What we can do is we can decide to filter all the papers. So for example, I can ask for the software to only consider the papers of the last 2 years because I want the latest of the latest. I want only the papers in the highest impact journals, for example, and I want it to regenerate the summary. And then I think this is kind of a miracle of AI. It just regenerates the summary based on these parameters. So completely rewrites the summary with these specific changing parameters. And you see, for example, the consensus meter. Yeah. In German, we say Vorführeffekt. Well, the consensus meter changes. Trust me. And so, as you can see, this is really easy to use. It's a very user-friendly system, and it's a really something that you can just click your way through. And so for example, a consensus meter change. Let's go back to the presentation. Consensus, however, is only an example of how customized AI models can enhance the efficiency of academic workflows. And this is to mention that we are keeping there. We are trying to help you there any way we can. Other promising directions include review writing, so you can use this system to write an entire to help you to do a lot of the tedious work into writing a review. Of course, you have to stay on. You have to continue being the captain of the ship. You have to make the decisions, but the AI can help you speed up the process. It can help you writing grants, especially for EU grants, which are very formatting heavy. And data analysis, for example, suggest analysis and provide you Python code. And teaching and learning GPT, for example, customized AI tutors for students. In conclusion, it is very likely that competitiveness of a research institution may be soon shaped not only by smart minds, infrastructure and funding, but also by the quality of the AI model they deploy to augment their workflow. And we will keep at the cutting edge to help you stay at the cutting edge. Thank you for your attention.